So what product rule says that if a job A can be done in m ways, and after it is done, another job B can be done in n ways. All right. So total number of ways would be m into n. Like there is a question. Uh, just read it and try to answer it. It's easy enough. So 150. Okay, fine. So the logic is pretty simple, right? Uh, just we have to take one boy and one from 15 boys and one girl from 10 girls. So we have 15 options for boys and 10 options for girls. So it is 150, right? If I ask the same question now, but just I change from like you have to form a team of either one boy or one girl, then what will be the number of ways? Okay, 25. 25. Okay, fine. So the answer would be 25 because now you have to take uh, one boy or one girl from a group of whole 25 persons, right? So this is some rule. Like we always apply some rule where either one job has to be done. Okay, and the product rule where both jobs has to be done. Okay, if there is all right, so I'll be going pretty fast because you have done all these things earlier. All right, so if any doubt, if you have any doubt in between, you can just unmute yourself and ask. All right. Okay, so let's say I have n distinct objects and I want to find the number of ways to arrange these n objects. All right, so how I can do that? Right, that's n factorial. Yeah. So we are just here applying the product rule. That is, first we can first we can place one of them, then we can place the second one. For the second one, there will only be n minus options left. For third one, only n minus two, and so on up to one. So that will be your n factorial. Okay, all right. Okay, so I have given a string to you which contains of some numbers, different numbers of letters. So what are the number of ways to arrange them? Total number of ways. Like for this specific example, you can answer. There are 3x, 2y's, and 4z's. Okay. Okay, Lavesh. Sorry, Lavkesh. This will not be plus. This is actually multiplication. You have to do. Okay, so I have got, yeah. So I have got one answer. Okay. People are still joining. Okay, okay. So everyone understand this, right? Is there any need for me to explain this further? Like if you understand this, doesn't just write one. So the total, yeah. So the total number of ways to arrange the letters would be 9 factorial, and then there are three x's, so their arrangement doesn't matter. So we'll divide it by 3 factorial, same as for y and z's. Okay. So let's move on. So you guys obviously know about permutation, right? So if we want to arrange n objects, uh, not n objects, like if there are n objects and we want to arrange any r of them, where order matters. All right, like 1 2 and 2 1, that matters. So there will be npr ways, right? That's the logic you have applied to find the answer of the above problem, right? So we also call it NPR, that is the number of permutations. Okay. But if I ask you to just select R objects from N and don't arrange them, then what will be the number of ways? Yeah, yeah, that's right. NCR. Okay. So just when order matters, there are n factorial divided by n minus r factorial ways, and and when the order doesn't matter, then we just have to select, so we will divide it by another r factorial. Okay, because there are r objects. Okay, so till here, is there anyone who has any doubt? Like it's just your simple JE things, and there is nothing new about it. You see, the reason why I'm teaching this topics is because several companies in their coding rounds take aptitude tests. All right, in which they ask this the questions based on combination, permutations, and symbol or mathematics and puzzles. Right. So it's important so you know about them. Okay, and we are also going to discuss some results. Okay. Okay, so there are no doubts, I believe. Okay, so let's move on. There are some properties of the binomial coefficients. You may have know about them, and you have proven even some, I believe. Okay, so the first three, like NC, NC naught plus NC1 up to NCN, it is 2 raised to the power n. And if we take only even terms or either odd terms, then it will be 2 raised to the power n minus 1. Okay, the first three you should have known, and the other ones, uh, you might have proved them at some point of time. I'm not here going to discuss the proof of these. You have already done this, or you can check on net. All right. These are some just results that you should remember. Okay. 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 So if I want to find out a factorial of a number, let's say the number is n, Let's say the number is n. I want to find out n factorial modulo m. So how should I do this? Anyone can answer or just write their logic.
सर सिंपल फोर लूप लगा देंगे और बार बार मॉड लेते जाएंगे.
हाँ सही है. ओके सो जैसा अभी ने अभी कहा एक सिंपल हम फॉर लूप लगा देंगे एंड बार बार मॉड्यूलो लेते जाएंगे. ओके सो like if I want to calculate all the factorials, let's say to from 1 to n is then I can simply store them in a array. All right, and just I'll use the for loop. In the factorial of I can say it will be the factorial of I minus 1 into I. Factorial of n. Like I have calculated all the factorials from 1 to n. So in this code I have made a mistake. Can anyone found that?
सर फैक्टोरियल ऑफ जीरो इनिशियलाइज करना पड़ेगा.
Yeah, right. So we have to initialize factorial of 0. That's okay. And और
फिर एक स्टेप पे मॉड लेंगे फिर.
yeah. So I believe these are pretty simple things. You can understand, right? Like, is there anyone who did not understand this? Okay. So, all right. Okay. So, how to compute NCR mod m when m is not necessary prime? You can just ignore this part that m is not necessarily prime. Just tell me how will you calculate NCR mod m? Like obviously, let me just write it. NCR may or may not be NCR might be greater than 10 raised to the power 18. Right. So we can calculate n factorial, r factorial, and n minus r factorial separately. Okay. So Amrut, like what you said, that is correct. You can find them separately, but we have to divide the r factorial and n minus r factorial by n factorial by r factorial and n minus r factorial, their product. So we can't just do that. All right. Because like you have studied about a by b modulo m concept in number theory, right? Okay. So Anand, like the solution you have written, answer is n factorial of n. What is k here? Can you speak just now? Inverse modulo. Okay. K is r. Okay. Binary exponentiation. Okay, so the concept you are using, like Manish also said, inverse modulo. Uh, yeah, Samir. Okay. Yeah, so you can't use inverse modulo here. Okay, because well, I have told you to ignore this part, but inverse modulo can only be used when m is prime. Okay. According to Fermat's theorem, just let me lightly. Inverse modulo can only be when m is prime. All right. So you can't use inverse modulo here. Okay. Okay. Hmm. Okay. So I have found one answer here, that is, okay. So Piyush has written something. Okay, n by r. Okay. So Piyush, the problem with your code is like you are using n and r, but there may be a chance. There might be cases when n is not completely divisible by r, right? So in that case, your code fails. Okay, did you get it? Yeah. Okay. So Samir has written the correct one. You are just use the property of your combination, that is here the seventh property, right? Okay. So just use this property to find NCR modulo m in a recursive way. Okay. So let me just code it. Okay. So just NCR n r m n. So you just have to return NCR n minus 1 r minus 1 plus NCR n minus 1 r. So the m also would be here. So you can just find NCR by this method. And what would be the base cases? Can someone write them in the chat? Yeah, Samir, then we will do DP. Yeah, that's fine. Okay, so what will be the base cases? R is equal to 0, return 1. Okay. R is equal to n, return n. Hmm. Okay, so just return r is equal to 1 return and okay, r is equal to 1 you want to say. Okay, fine. And less than equal to r return and okay, so Ritesh, when n is less than equal to r, it won't be return 0. Like it will only be for n less than r. Alright, when n is equal to r, then we will return 1. Right, ncn. Yeah. Okay, so just complete it. So when r is greater than n, we'll return 0. If r is equal to 0 or r is equal to n, we will return 1. And obviously, we are calculating some things more than one time. So we can just use dp. So just let me initialize the dp. dp okay, constant max. So I'm initializing the dp with -1. Okay. So if dp of n comma r is not equal to -1, then we will just return dp and r, and we will store it when we are returning. Okay, so I guess this is fine. So is there any doubt? Like we have just used the property, like this seventh property, that ncr is equal to n minus 1 cr plus n minus 1 cr minus 1. All right. And at every point we have to take the mod. Okay. Okay. So just write 1 or 0. So what will be its time complexity? Okay, so everyone did understand. Yeah, so what will be its time complexity? O of r. Okay. Like, are you sure? So yeah, so it will be O of n into r. I guess everyone didn't understand it. N can decrease from can decrease to 0, and R will also be, and we will also be at max storing N into R elements in our DP. Okay, in calculating them. So the time complexity will be N into R, and what will be the space complexity? Yes, let me write it. Yeah. Okay, so fine. So as you can see, we can only calculate NCR by this method for a small when N and R are small, that is less than equal to 10 raised to the power 3. Uh, all right. So what if N and R are greater? And in this, I have also given that M is prime. So someone of you has also has already answered this, I believe. Right, mod inverse. Okay, so you guys know about mod inverse, right? I don't need to explain this mod inverse thing. Okay. Okay. Okay, fine. So let's just code it. So same for the previous question, like not previous, like when we calculated the factorial of n, we will first pre-compute all factorials up to n, and then you can simplify NCR.
स्क्रीन शेयर ऑफ हो गया देखना।
हाँ देख रहा हूँ देख रहा हूँ। Can you see my screen?
हाँ ठीक है।
Yeah, okay, sorry about that. So we can simply find it out. I return factorial of n into inverse of just like that. Inverse of factorial of r into inverse of factorial of n minus r. Okay, so every time take mod, obviously. Inverse of this, inverse of this. Whenever you multiply, take mod. Otherwise, your answer may exceed m. Right. So yeah, so what will be its time complexity? Like, don't include this pre-computations. Okay, that will be O of n. Just tell me the time complexity of this NCR function.
विशाल एन लॉगिन क्यों बोल रहे हो? हाँ, इनवर्स निकालने का लॉगिन होता है वैसे। एक नंबर का इनवर्स निकालोगे वो लॉगिन टाइम होता है।
Okay, so yeah, it will be O of log n simply for just this NCR function, because the factorial of n is already pre-computed. Factorial of r and n minus r. You just have to find the inverse, right? And inverse, I believe all of you know how to find. Just write it by Fermat's theorem. Inverse of n mod m would be equal to n raised to the power m minus 2 mod n. Okay, I believe all of you know that. It's in number theory. Yes. Yeah. So now think how to do it in O of 1.
लाइक अभी तक हम क्या प्री कंप्यूट कर रहे हैं? बस फैक्टोरियल प्री कंप्यूट कर रहे हैं ना, तो इसके अलावा और क्या काम कर सकते हैं कि पूरा ऑपरेशन ऑर्डर ऑफ बनना हो जाए? इनवर्स
So-
प्री कंप्यूट कर लो फिर।
Yeah. So you can also pre-compute inverse factorial up to n. All right. So that depends on your needs. Like if you want.
हाँ, तो क्वेश्चन है तुमको यूज क्या करना है, प्री कंप्यूटेड या फिर लाइव एनसीआर कैलकुलेशन जिसमें इनवर्स कैलकुलेट होगा?
So that depends on your needs. Like if you want to find this NCR for only one time, then there is no need to pre-compute all the inverse factorials, obviously, because that then the time complexity will increase. All right. But if you want to find out this value for all n and r, then obviously the need would be different, right? So it just depends on the question and how you will think it. ओके, सो यहाँ तक अभी तक किसी को कोई डाउट है? वन जीरो लिख दो। सो अगर 1E18 है तो इनवर्स प्री कंप्यूट हो पाएगा या राइट। सो 1E18 में इनवर्स हम प्री कंप्यूट नहीं कर सकते, उस पर अभी आएंगे कि उस सिचुएशन को कैसे डील करना है। Okay, so any doubt till now? Believe there is. Okay, so let's move on. So the next question, like this is the question: how to compute NCR mod m? M is obviously prime, but now you see the range of n and r. They are up to 10 raised to the power 18. Right. So how can you do this? Just take 2 to 3 minutes. If anyone of you knows. Like, just see the constraints of m. It's up to 10 raised to the power 6. Okay, so try to use it. Like, maybe you have studied the theorem for it. I don't know. Okay. And we perform modulo of m into n. Try using phi of n. Okay. Okay. So just let me tell you. Have you known of this algorithm, Lucas theorem? Did anyone of you know about it? Just write 0 1. Okay. Oh, so none of you studied about this. Okay, all right, no problem. So what Lucas theorem says that if we want to find out NCR modulo m, then what we can do is we have to write n and r in base m. Like initially, it is written in decimal, right, in base 10, and your binary numbers are in base 2. So similarly, we have to write n and r in base m. Okay, so just let me show you. Just let me use the equations bar. Okay. Okay, so yeah. Okay. So if we write n in the base m, you can just write it like this up to n0. Similarly, you can also write r like r k minus 1 and r k minus 2 are 0. Right. So you just have to write n in base m and write r in base m. Okay. After that, NCR mod modulo m would be equal to, and just let me copy this. Into modulo m and do this thing for all the k digits. Like I'm writing it m. So let's say there are k digits up to n0 to n of k minus 1, and for r that is r0 to r of k minus 1. So take the NCR for every digit. All right. Just so modulo m. So this is what Lucas theorem say. All right. Uh, there is no other matter. You just have to remember this. Okay. So do you guys know about how to convert a number into base m, like for any other number? Yes. Okay. So is there anyone who doesn't know? Like, yeah, just write 10. Just if you okay, so just let me tell you how to do this. So okay, so if you have any number n and you want to write it in base m, so the most simple, so how can you write this is, first you will divide it. I am let's just take an example. For example, there is 9. You want to write in modulo 3. Yeah, okay, for simplicity first we take 2 modulo 2. So when we divide it, the remainder will be 1, right? And the question, our question would be 4 left. Okay, then we again divide it. So this time the remainder would be 0. Like I'm writing the remainders here. Okay, from right to left. So what will be left? Again 2. So this time the remainder will also, this time also it's 0. And finally we have, so this time the remainder would be 1. Okay, so this is what how, so this is what 9 in binary, 1001. Okay,
शिवम कुछ टाइप कर रहा है क्या? दिख नहीं रहा है।
अच्छा दिख नहीं रहा है क्या?
डॉक में भी नहीं शो हो रहा।
Okay, okay. Oh, sorry about that.
अच्छा अच्छा ठीक है
Okay, so what I'm telling is, like if you want to write 9 in binary in base 2, that is, so what will you do? You will first divide it by 2. All right, so the remainder would be 1 here. Then after that the remaining, the question that is, that will be 4. Then you will again divide it. You will continue dividing until your question would be 0. Okay, so for then we divide it by 4, so the remainder would be 0. You will be storing the remainder simultaneously. Then we will divide it by we will divide 2 by 2, so that will also be remainder 0. And after that 1 would be divided by 2, so the remainder would be 1. Okay, so this is how we have to use it for. Okay, just delete it all. Okay, all right. Okay, so similarly, if you want to write 9 in base 3, how can you do this? First you will divide. So can anyone answer this? One zero zero 30 100. Okay. Okay, yeah. So it will be 100. See, Pradeep, whenever you write an answer in base m, there can never be a digit which is greater than or equal to that base. All right. So so 30 won't be there. Okay. Yeah. So let me. Right. Okay. Just try to do this. Just take one or two more examples, like 15 in base 4. Three. Okay. Okay. So I believe everyone understand it. So the people who didn't knew about it at first, those who have written 0, do you understand it? Yes, then write one. Just Aviral, Supesh, did you get it? Okay. Okay. So Aviral, did you get it? He is in the meet, right? Okay. So no response. Okay. So I believe now that everyone get it. So let's try to code it. So NCR. So just do it share. You can see the doc right now. Okay. So just in NCR and temp. m. So just we simply at that digit place of n, we can take it as n modulo m. Digit for r would be r modulo m, and we can just return, let's name it NCR digits. All right. Okay. Okay. So n CR digits. So what I'm doing here is I'm passing the remainders onto another function, that is NCR digits, and for the rest of the number, I'm just calling this function once again, that is n by m, r by n. All right. And what would be the base condition? Oh, this should be multiply. Okay. Below. Yeah, so n r is greater than n, then return n. Yeah. Okay. How is this? If r is greater than n, then you are returning n. How? Okay.
बेस खंड है एंड नंबर 4 हो गई, फिर तुम उसकी मतलब वो टर्न कर
Sorry, I didn't able to hear you properly. Can you write it? What you are saying?
वॉइस क्रैक कर रही है एक्चुअली.
Okay, so r is equal to n, then return 1. Yeah, that's right. And there will be one more condition. Okay, okay, fine. So Abhishek, yeah, that's completely correct. When n is equal to 0. Okay. So what we can do is, like, we are obviously assuming, like, whenever we are finding out NCR, I'm assuming that r is less than equal to n, right? So if so, instead of writing n equal to 0, I can just write r is equal to 0. Okay. So because r is obviously less than m, so r will become 0 first. All right. Before n becomes 0. So I can just write like this. And the second condition, which is r is greater than n. That will never happen here actually, because you see, n is greater than r, and n divided by m at any point would also be greater than r divided by m, right? So there won't ever be a condition when r is greater than m. Okay, did everybody get it, or is there any doubt? Okay. Okay. NCR digits नहीं समझ. Okay, I will tell about NCR digits. So NCR, it is nothing but you just have to use the above NCR function. NCR function, that is, mm, okay, yeah, this one. You just have to use it. Just factorial and inverse, because now n, r, and m, all of them would be less than equal to m, and obviously you will pre-compute all factorials up to n. So just you need to use this function to calculate NCR digits. Okay, NCR digits is nothing new.
जस्ट ये नोट कर लेना कि जो एनसीआर डिजिट्स में एन और आर जा रहा है वो हमेशा एम से छोटा होगा.
Yeah,
तो उसका रेंज
like I'm
1 6 होगा.
passing this.
मॉड करके भेज रहे हैं तो एम से छोटा जाएगा वो वैल्यू. सो यू कैन यूज प्री कंप्यूटेड फंक्शन फॉर दैट.
Okay. Okay. So what about the rest of? Did you get it or not? Uh, okay. Okay, I believe. Right. Okay, so can you tell me the time complexity for this NCR function? It's Yeah, anyone just write it in the chat. O of m for pre-compute. Yeah, you can just ignore the pre-computation part. All right. Just tell me of this NCR and O of log n base m for NCR. Okay. O of log r. Yes, instead of r we can use n because okay, so log r. Wait a minute. R small. Okay, okay. Yeah. Yeah, that's fine. Fine. Yeah. O of log r. That's all. That also works. Yeah, okay. So that will be log of r to the base m. All right. uh, and also whenever I'm calling this function, like in the function ncr, I'm calling the function ncr digits also, right? So so this will be log r to the base m into the time complexity of ncr digits. Okay, so that we have already discussed above. All right. uh, just yes. Yeah. Okay, so is there any confusion, like why is it here log r not log n? It's because whenever r is smaller than n, so whenever r will be 0, we are just returning 1. So there is no need for us to go for n digit, n, right? So who, is there anyone who didn't understand this? Just write it in the chat. That what part didn't you understand? Okay. Okay. If you understand it, then just write 1. I just need to check. Okay. Okay. So like I'm seeing 68 participants and only 5-6 people are writing 1. What about the rest of you? Are you getting it or not? Yeah. Okay. So until I say something, you won't, you aren't going to write 1. Is that it? Okay. Okay. Fine. Fine. So let's go on. There is a question regarding this. Just get to the question. Okay. Okay. Why isn't it showing anything? Okay. All of you can just open the link, right? I don't know why is it not open. It's just blank.
एक बार सबमिशन में जाके वापस डिटेल्स में आना.
Oh yeah. Okay. चल रहा है. Okay. So you can just read the question. It is nothing but the same concept, that is Lucas theorem that we just learned. You can see the x and y, their range is up to 10 raised to the power 16, but you have to find it mod 99 prime number. Okay, so it is less than 10 raised to the power 6. So you can just try to do this question. It's good for practice. Just you have to use the same thing. There's nothing extraordinary in this question, so I believe you can do it. All right. So just try that question once after the class. Okay. Okay. So let's just move on. Okay. Oh, this one is also left. Okay. So you have to find you will find very less number of questions like this where you have to find the NCR with no modulo. There isn't any modulo, and given n is less than 50, there are some constraints, but it is sure shot that NCR which you have to find out is less than 10 raised to the power 18. Okay, this is guaranteed. So if this type of question comes, then how will you do it? Like 50x factorial exceeds 10 raised to the power 18, but 50c 25 is less than. So we can obviously store it in long. Okay, so just give it a try. Take 2 to 3 minutes. NCR is equal to NCN minus R. So up to 25, how will you do it? Like 50C25 will be 50C25 in this case. Can you unmute yourself, Vishal?
जी सर मतलब कि 50 से 25 तक के सारे निकाल देंगे तो हाफ तक पहुंच जाएगा 1 टू लिखेगा 25। अच्छा सॉरी 50 से 25 एकदम हाँ सही बोल रहा हूँ सर 50 से 25 तक के निकालेंगे तो उसके बाद सिमेट्री आना है 50 से 26 जो होगा वो 50 से 94 होगा ऐसे।
या वो तो सिमेट्री आ जाएगा, दैट इज करेक्ट, लेकिन ये हम निकालेंगे कैसे? बिकॉज 50 फैक्टोरियल एक्सीड्स कर जाता है एंड देयर इज नो मॉड्यूलो. Okay. Okay, so each step we divide by GCD of denominator and numerator. Okay. Chaitanya, can you please explain it a bit further? If you can unmute yourself. Like you are kind of going in the right direction. You can calculate numerator, and then at each step we find GCD and divide it. Okay. Okay, I guess this will work, but okay, this will work, but the GCD, it will also take some time, right? I don't want to use it GCD. Like what I understand, you are trying to say that first we write 50, and then in the denominator there will be 25, and into 25 something like this. 50 factorial by 25 factorial into 25, and then we just take GCD and divide both numerator and denominator, and we will do this at each and every step. Yeah, that will work, but I don't want to use the GCD. Okay, we can use like above. Yeah, okay. r greater than n by 2, r is equal to, yeah, that's fine, Abhishek, but we want to find out 50C25. How we'll reach it? Store it in dp. Okay. Okay. So you have just written the okay binary. See, Ritesh, you can't do this binary exponentiation. The reason is we haven't been given a value of mod. Okay, there is no mod. So if you take, okay, and Siddharth, can you please unmute yourself? Like I didn't get what you are trying to say.
Sir, I was saying, like we can calculate the previous states by using DP. So we only have to calculate combinatorics, not factorial.
Okay, just like this.
Yes, sir.
Okay. And okay. Yeah, that will be fine. But like the example I have written here is just 50C25. Okay. So it will work for that. But if the number are very large, like let's say 10 raised to the power 5C some number, but it is guaranteed that the combination would be less than 10 raised to the power 18. Then in that case we can't create a DP, right? Like for this
Yes,
example,
sir.
yeah, for this example, that DP approach will work. But if the numbers are larger, then it won't work. Okay, so just let me explain it. So you can see the whiteboard, right? Yeah, you all are able to see it, right?
हाँ 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 right.
Okay. So what you can do is just write NCR as what you can write is N by R. Okay. Just let me check it. Is there anything wrong? Yeah. So you can write it like this, right? So yeah. So there might be chances that n is not divisible by r. So you can again write n minus 1 cr minus 1 in this form. So it will be n minus 1 divided by r minus 1 into n minus 2 cr minus 2. Okay. So everybody get this right? So in this approach, what we will do is that because there are chances that n is not divisible by r, so we will take the numerator from the left hand side and the denominators from the right hand side. Okay, so it will go up to when r will be 0, right? So we'll take numerators from this side and denominators from this side, so that if we take first number here n, we will divide it by 1. Then we will take the second number n minus 1 and then divide it by 2. So either one of them is definitely guaranteed to be divisible by 2, right? Because there are two numbers. If this is not divisible, then the other one. Then we will take n minus 2 and divide it by 3. Okay. So one of the three will be divisible by 3. So are you able to get this? Just write 0, 1. Yeah, basically what I am doing is like n factorial is divided by r factorial into n minus r. So I'm just taking the terms from the numerator, okay, up to n minus r plus 1. Okay, n minus r factorial I have cancelled, and the denominators I am taking r factorial. Okay, if you just consider it writing this way, then it will go up to n minus r. Okay, it will go from n to n minus r plus 1, the numerator, and r will go from r to 1. Okay, so is there any doubt in this? Hmm. Like if you are not able to understand, then just write it. I will explain it again. Okay. Okay, so I am not seeing any responses. Like what happened? Like you can understand this first part, right? We can write NCR as n by r into n minus 1 CR minus 1, right? This first part. After that, what I'm just doing is in the numerator and the denominator, there will be r terms. In the denominator, that will be up to from 1 to r, and the numerator will be n minus r plus 1 up to n. Okay, so I am just taking the numerator from the left hand side, that is the highest number n, and moving to and multiplying, and each step multiplying it by n, the just less number, one less number. Okay, and the denominator I am taking from the right hand side from 1, and at every point I am dividing my answer by 1, then 2, then 3, up to r. Okay. Okay, so did anyone understand?
Like the basic restriction was that you can't do n by r, but you can do n minus r plus 1 by 1, and you can do n minus r plus 2 by 2, because among those two numbers one of them is guaranteed to be divisible by 2.
Yeah.
Like among two consecutive numbers one of them is guaranteed to be divisible by 2. Among three consecutive numbers one of them is guaranteed to be divisible by 3. So you keep on doing this. You go from 1 to r and you go from n minus r plus 1 up to n. Just apply a reverse loop and it will work fine.
Okay, so should I code it, or did you guys have any doubt in this? Just ask.
Aman, the question says that your final answer would not overflow. So at last you will get the value of NCR and that will not overflow according to the question.
Okay. Okay, fine. So just let me code it. So I will store my answer in the answer variable, and I will just start a for loop from I equal to 1 to r. Right. Each step I will multiply my answer by n minus I plus 1, and then divide by my answer by I, and just return the answer. So at first put value of I equal to 1, it will be n, answer into n, then divided by 1. Then answer into n minus 1, answer divided by 2. Okay, so just keep on repeating this.
Otherwise you can also write recursive function for this, which is better to understand. But iterative is also fine.
Hello, am I audible?
हाँ आ रही है also.
ठीक है. So the code is pretty simple. I believe everyone get that. Just write 1 or 0. Okay, fine.
Now it is your decision to see like what is the need of the question and which type of NCR I have to calculate.
Yeah,
So
like
mostly you will be calculating that pre-computation thing in most of the questions.
like in most of the questions, you will do this NCR modem when m is prime, just inverse. Okay, but there are some questions that you will have to use different methods.
So keep in mind all the methods, and according to the need of the question you might need that. Questions are rare, but you might need that.
Okay, so we have discussed all 4 variations. Okay, so let's move on to the next question. Okay, so let's say you are at the origin of a grid 0, 0, and you need to reach to n, m, and you can move only in 2 directions, up and right. Okay, then you have to find the number of ways. Total number of ways to do this. to reach n comma m. So how can you do this question?
शिवा एक ग्रिड बनाते हैं फिर दिखाते हैं
Yeah, yeah.
गूगल डॉक में
Here. Okay. Okay. Yeah, that's correct. Okay. Okay, so we can do this in n plus m factorial divided by n factorial and m factorial. Like what you can do this any sequence by which you can reach to the end. Let's say I'm taking this sequence. So first I'm moving right, then up, then I'm moving right 3 times, and then up. So there will always be n times I have to move up and m times I have to move right. Right. Okay. So you can see this question by another way, that there is a string, the string which is there are only r and u, and you want to find the total number of ways to arrange this string. So that will be n plus m cn or cm, whatever. All right. Like plus m cm. Okay. Is there anyone who has a doubt in this?
ऐसे वो सब बताया था क्या नंबर ऑफ आंसर्स टू द लीनियर इक्वेशन सर्कुलर वो सब नहीं बताया ना अभी
नहीं, वो नहीं बताया।
अच्छा
Like-
इसके बाद करा देता हूँ
ठीक है।
कैटलाइन नंबर फिर बाद में स्टार्ट करना है
अच्छा, ओके, ठीक।
अच्छा लाइक इसमें कोई डाउट है कि ये लाइक जो भी स्ट्रिंग होगा वो आर यू का कॉम्बिनेशन होगा एंड रिपीटेड परम्यूटेशंस कैसे निकालते हैं जिसमें लाइक सर्टेन वैल्यू रिपीट कर रही होती है दैट इज n प्लस m द टोटल स्ट्रिंग साइज फैक्टोरियल उसका डिवाइडेड बाय द रिपीटेशंस वाला पार्ट n फैक्टोरियल एंड m फैक्टोरियल अच्छा मैं स्क्रीन शेयर करके वो पार्ट करा देता हूँ अभी ठीक है
ठीक है।
So let us start with a question. There is one equation given to you. x1 plus x2 plus x3 plus x4 up to some xk. and sum of these must be n. The constraint is that xi must be greater than equal to 1. Okay, yeah. So this is the constraint, and you have to fill this. We have to like find integral solutions for this, like any value of x1, any value of x2, such that the total sum of this thing is equal to n. N must be greater than equal to 1. Like, have you done this question during your JE time or anything? Something related to this, if you can remember. So you have is greater than equal to 0. So just make a slight change for this thing. Yeah, n minus 1 cr minus 1. Okay, is there anyone who doesn't know the formula? Oh, or has no idea how this comes? Of this, this is equivalent to finding coefficient of x to the power n minus k in the expansion of minus x to the power minus k, which is equal to n minus 1 ck minus 1 or n minus 1 cr minus 1. If you expand this thing, then there will be many coefficients, and among them, the one having the coefficient of this term will be your answer.
There is one other way of proving this. Like, let's say if you, yeah, वो भी बता दो.
हाँ बता दे.
Okay, so let's say there are n candies or n spaces, whatever. Okay, and you have to partition it into. You have to partition it into.
अच्छा रुक मैं बता देता हूँ, अटक गया है.
Just wait a minute.
Okay, so there are many candies, and you have to give some k minus 1 partitions. Okay, among this.
Yeah.
And by partition I mean you can divide, give a boundary between them. So suppose I give a partition here. Now this will be another thing, and this will be another thing. This will be another thing. So like that you can give k minus 1 partitions. Now what is the result of that? On giving k minus 1 partitions, and between each partition, between any two partition, there must be at least one candy. Okay, so when you gave k minus 1 partitions, the result was that you got k groups. Like this is the first, second, third, fourth, and this is the last one, fifth. On giving 4 partitions, I get 5 groups. So now think what is the number of ways to give partitions in this. Like first of all, see how many spots are there to give partitions, and among them how many partitions you have to choose. One thing that I know is that I have to give k minus 1 partitions. Now tell me what is the total number of partitions there. Like total number of spots where I can place a partition. And that is the answer, but just count the total number of partitions. 1, 2, 3, 4, like this. For n objects, you will get n minus 1 partisans. That's right. Okay. And among them, you give k minus 1 partisans. So simple ways to do that is to n minus 1 c k minus 1. Among n minus 1 objects, you chose k minus 1. Okay. Any k minus 1. The order doesn't matter here. So now you can replace each group by x1 variable, second one by x2, the third one by x3, fourth one by x4, and last one by x5. Okay. So, and the total sum is obviously n. So if I ask a simple answer to this, then it will be n minus 1 ck minus 1. Like these two things are similar if you compare them. Okay. Now I hope that the explanation is clear. So just write 1 if you understand, and if anyone doesn't understand still, then you can write 0. And rest of the people. Okay, fine. So this was one thing. Now let's talk about similar question, but this time I will relax the constraints to xi is greater than equal to 0. Now what can be the answer for this? Like every xi is greater than, can be greater than equal to 0. So if anyone wants to speak about its derivation or any logic on how to get this using this formula, can you derive an answer for this? Like here xi was greater than equal to 1, here xi can be greater than equal to 0. Okay, n plus k minus 1 is k minus 1. Yeah, answer is right. But let me just speak about briefly about the derivation of this. You see, xi is greater than equal to 0. This means that xi plus 1 is greater than equal to 1. So just make a small change. Add k to both the sides of the equation. So replace every xi by xi plus 1, x2 plus 1, x3 plus 1, and keep on doing this up to xk plus 1. And here on the left hand side, right hand side, you can just add n plus k. The equation still remains valid. Now, what is the solution to this thing? Like this can be considered now as a single term, x1 plus 1. So you can replace it as y1 plus y2 plus y3 plus y4 up to yk, that is equal to n plus k. Okay. Now you know that y1 is greater than equal to 1 because y1 is simply x1 plus 1, and any yi is simply xi plus 1. Okay. So the solution to this will be n plus k minus 1 and c k minus 1. Just a small change that n got replaced by n plus k. Okay. So the answer will be just n plus k minus 1 c k minus 1. Okay, considering with the partitions case, now there are n plus r minus 1 places available. So yeah, you can make a blank partition too in this case. So like simply you can overlap the partitions. That is also one way to imagine. Fine. So if this is clear, then like this is just the theory part. Questions, if we can get, then we will explain. Let's talk about circular permutations.
वो जनरलाइज्ड ये बता ही दे.
Generalized कौन सा?
जैसे x plus c के लिए कह लें x is greater than equal to c.
अच्छा, ये भी देख लेना. Now if you think
आप
that
खुद भी डिराइव कर सकते हैं वैसे ये.
हाँ, I take this as a homework. That now there are many variables x1 plus x2 plus x3 plus x4 up to xk is equal to n. But now there are varying constants like x1 is greater than some y1, x2 is greater than equal to some other y2. Now y1 can be any number from 1 to n or 0 to n, whatever you can find. Then x3 can be any other number, y3. So there are like varying constants, not a uniform one. So in this case, just to derive the answer, what you can do, you can change each variable. Like you know that x1 is greater than y1. So you do x1 minus y1 is greater than equal to 0. Convert this to x2 minus y2 is greater than equal to 0. And this gets converted to x3 minus y3 is greater than equal to 0. Okay. So replace each of the terms by this thing, and to keep the equation valid, add or subtract, like you will subtract from n the sum of y1, y2, y3 and all those things. Then after you have got another equation, this will be analogous to this equation, this one, where n will get changed obviously, and the constants will be uniform now, and they are all greater than 0 now. So you can bring them into a uniform configuration after manipulating the variables, and then you can apply the formula for this. Like n will be changed and this thing will remain same, k minus 1, but n will get changed. Okay. So if this much is clear, then just write 1. Any person who has the slightest doubt here, like something you don't find comforting or anything, something is not clicking you. Okay. So let's talk about circular permutations. Now the number of ways to arrange given objects on a circle, right? So now there are two things here. The case where you will consider anti-clockwise and clockwise combinations differently, and a case like where anti-clockwise and clockwise combinations are considered different. So the answer to this will be n minus 1 factorial. In the case where so this time you have don't have any restriction on what is the number of ways. So for this you will just divide by 2. Like if they are different, then every configuration can be seen in the mirror way too. Right? If there is any clockwise configuration, then for that an anti-clockwise configuration also exists. Now if you want to consider them same, then just divide by 2. Okay. शिवम इसका कुछ वो था क्या जनरलाइज वाला के परम्यूटेशंस लाइक के कुछ के
क्या?
सर्कुलर में कुछ के का था क्या?
नहीं, सर्कुलर में के का नहीं था कुछ।
याद नहीं आ रहा ठीक से। लाइक तुम में से किसी को याद है कुछ के का रिस्ट्रिक्शन वाला था इसमें? सर गैप एम फिल करने वाला था।
के
एक मिनट देख लेता हूँ। आई थिंक सीपी में इतना आता नहीं है वो कि के को रिस्ट्रिक्शन वाला काम।
सीपी में नहीं आएगा, बट वही एप्टीट्यूड टेस्ट में आ सकता है।
हाँ एप्टीट्यूड टेस्ट, और तुमको अगर मैथ में कुछ देखना है लाइक नो टू एडजेसेंट केस। यहाँ पे सिंपल ही है, पता नहीं वो कुछ आर्टिकल मिलेगा तो मैं भेज दूंगा, बट एग्जैक्टली याद नहीं आ रहा क्वेश्चन क्या था वो। अब लास्ट में एक चीज देखते हैं, मल्टीनोमियल थ्योरम। ओके, सो बेसिकली वही आर यू वाला चीज जो अभी हुआ था। देयर इज अ कॉम्बिनेशन ऑफ आर यू ऐसे, you need to find the permutations of this. Like let's add more variables bd and l true. तो ऐसा स्ट्रिंग दे रखा है and find the number of permutations of this. So इसका वही सिंपल आंसर था कि टोटल लेंथ ऑफ स्ट्रिंग जो n फैक्टोरियल होगा उसको डिवाइड करना है। सबसे पहले n ऑफ r मतलब n r का काउंट, देन डिवाइडेड बाय n u का काउंट डिवाइडेड बाय n l का काउंट n l फैक्टोरियल का काउंट, देन r u d। तो इसको जनरलाइज क्वेश्चन के फॉर्म में ऐसे बोल सकते हैं, लेट मी फ्रेम ए क्वेश्चन। सपोज देयर आर n items given and you need to distribute them into groups of size a1 a2 a3 a4 and so on up to ak, okay, such that क्या होगा कि set a1 plus a2 plus a3 plus a4 up to ak, टोटल सम n ही रहेगा आइटम्स का। देन इसके लिए तुम ऐसे कर सकते हो n फैक्टोरियल डिवाइडेड बाय a1 फैक्टोरियल टाइम्स a2 फैक्टोरियल टाइम्स a3 फैक्टोरियल टाइम्स ऐसे करके जाना, लास्ट में ak फैक्टोरियल। और तो वो प्रॉपर्टीज बता दिया था, हाँ ये वाली प्रॉपर्टीज। इसमें मोस्टली ऊपर के 4-5 सारे काम आते हैं, बट 6 थोड़ा रेयर होता है, बट ध्यान रखना अगर क्वेश्चन आ जाए तो ब्लैंक भी हो सकते हो, तो जस्ट देखते रहना, डॉक रेफर करते रहना इसके लिए। तो इतना था वो बेसिक्स ऑफ परम्यूटेशंस और कॉम्बिनेशंस. हाँ अब बता दे वो क्वेटलैंड नंबर. ठीक है.
अच्छा ठीक है. Yeah. Okay. So let's say there is a grid n cross n. Okay, and you are initially at 0 comma 0 origin, and you need to reach n comma n, and you can move in only two directions, up and right, but you can't cross the diagonal. Okay. Like you can't cross this diagonal. Then you have to find the number of ways to do this. Like basically, if you are write this as a sequence of r and u's, then the number of u's at any point cannot be greater than r. It can be equal to r, but it can't be greater than. Okay, like this one, they should be equal, but at any point the number of u's can't be greater than number of r's. So how to do this? Uh, well, one thing you can try to think of is what will be the total number of ways. Like it is n cross n, then the total number of ways to get to n comma n would be 2n cn, and in which there are ways in which the number of u's will be greater than r. So let's say that is k. Okay. So you want to find out this k. If this k is find out, then the valid ways will obviously find we will find that. Okay. Yes. Okay. So just take 2 to 3 minutes and try to think of it. How can you do this? Okay. So gap में fill करने वाला हूँ. Find ways to reach diagonal I comma I and subtract horizon. Sorry. Okay. Well, how will you find the number of ways to reach diagonal I comma I? Like you can go in both ways in which u greater than r also. Yes. निकाल लेंगे. Okay. K may be n by 2. How are you saying this? Okay. लाइक 0,0 टू. ओके, तुम अगर डायगोनल के बेस तुमने निकाल भी लिए तो उसके बाद उसे फिर यूज कैसे करोगे? और फर्स्ट ऑफ ऑल निकालोगे कैसे? लाइक कोई एक्सप्लेन कर सकता है क्या अनम्यूट करके? टू आई सी आई are ways to reach I. Okay, fine. Then how are you going to move forward with this? After reaching I, I, two ways exits. One will cross the diagonal and another will not. Okay. Okay, fine. Okay, like Chaitanya, can you unmute yourself?
Yes, sir.
Yeah. So, okay, you find out the number of ways to reach diagonal I, I. Okay. Then what were you plan to do after that?
So total number of ways will be 2 and to reach each diagonal, we'll calculate the number of ways to reach there, and then those many are the invalid ways. So we'll subtract each of the points.
Like, okay, so you are doing for that every point.
Yes, sir. For 1, 1, for 2, 2, 3, 3, and so on. But
Just
so they can be repeated also.
yeah, that's what I was thinking. So anyone else? Okay, फिर बताइए तो. Okay, so just see the screen. You can see the grid, right? Let's say this one way. It will be valid, right? And there is one other way. Okay. It will be invalid. All right. Or so what we are going to do now is all the invalid ways. Okay. In all the invalid ways, there must be a point where number of u's would be greater than number of r's, right? So okay, So when that point comes, after that we will reflect all u's and r's. From reflect, what I mean is we will replace u by r's and r's by u's. Okay, just let me explain it by showing you. So this path, well, r u r u u r. Okay, so r. So let's say this is my sequence. So at this point, the number of u's becomes greater than number of r's. So after this, the last one, I will reflect it. Okay, so I will change r to u. Okay, or let's take one bigger example. Like I'm change like just look at the last three characters. I've replaced r by u and u by r's. All right. So after that, just check this. Just check what will happen. Like at this point, let me change the color.